Hi, my name is Ricardo Ruiz, ID A01383658, and here is basically my explanation of the code. So firstly, we have the libraries. Then we start with the main, in which first we are configuring our first node, which will be named signal generator. Then we will establish the rate at which it will graph, which is 10 Hertz. Then we will publish the message, which will be with a float structure, and we establish a queue so that it starts saving the data. And I repeated that procedure twice, so one for the signal PUV and one for the time PUV. And each one of them has a named topic, which will be signal and time for each one. So now we have a signal generator and a signal and time. And then we establish the value of our current time, which will be 0. And we declare the variables for our new structure, which only will be, in my case, valor equals float32 and valor downscore tiempo equals float32. Then in our time, I basically established first the sinusoidal form, which will be my variable, which now is valor underscore señal equals np, the sinusoidal of my actual time. Then this is the calculus of our procedure. Then we will refill the structure. So the name of the variable dot the data, which means that the structure will be publishing that value. So it will be refreshing it. So I have valor dot data equals valor underscore señal, and I have valor underscore tiempo dot data equals tiempo actual. And the last step for the signal generator is just to publish the structure. So since we have made the equivalencies for the float32, so if you remember earlier, I mentioned that we had valor equals float32 and valor underscore equals float. So now we only use those variables for the signal PUV published and the time PUV published. And lastly, I just started an equation, a fast equation for the actual time. So the actual time will be equal to the actual time plus 0.1. So the time will be continuing. Now for the process, same thing, libraries. Then we declare two variables, the raw signal and the raw time. Then the offset and the reduction that we want for the next graph. And this will be in form of functions. So we have a signal callback and a time callback. So inside each one of them, we're just making equivalencies from the variables we established in the signal generator. So for example, the raw underscore signal will be equal to my valor.data, and my raw underscore time will be equal to the valor underscore tiempo.data. And now for the main function, here we just have another node which will be process. So now we have signal generator, time, signal, and now the process. And this one will be subscribed to the signal and the time, which were previously established. And then we publish another one, which will be for the process signal, which is it will be the last node, and also in float32 structure, and with a queue size of 10 also, and with a rate also of 10. And finally, we just make the final equation, which will be that the process value will be equal to the amount of reduction that we input times the raw signal, which is equal, if you remember, to the value.data plus the offset that we established. And that's basically it. So we have now two graphs. And here is the final results code.